Hey everybody, you know what time it is? It's time to talk about smog, the thing that's on everybody's mind, and finally we're going to piece it apart. Photochemical smog is one of the most common forms of air pollution throughout the world, and today we're going to talk about how it's formed, what impacts it has on us and the ecosystem, and what we can do about it. So there are two types of smog. There's industrial smog and there's photochemical smog. Industrial smog is this sort of historical, old-timey killer fog enveloped London in 1952, and it's basically just sulfur dioxides and particulates from coal combustion that create like a smog over the area. It's dangerous to breathe, of course. Photochemical smog, however, is formed through a chemical reaction. It's a little bit more complex than industrial smog. So, right, like I said, industrial smog is mostly sulfur dioxide and particulate matter. It's very, very dangerous to breathe. It's from burning coal and gasoline, and it's formed in cool, humid conditions. Here's some photos from London in 1952, and there were also some issues in Pennsylvania in 1948 with industrial smog. It can actually lead to the formation of acid rain as well. Photochemical smog, however, is a little bit more complicated. It's a mixture of primary and second pollutants that form and mix together under the influence of sunlight, and this kills you a lot slower. I will return to this diagram in a little bit, but it shows us that smog is a mixture of primary pollutants like NOx, VOCs, and secondary pollutants like ozone and something called PANs. So how is smog formed? Smog, like I just said, is a mixture of a lot of different things, but one of the primary components of smog is ozone, as well as things like particulate matter. And ozone is formed when nitrogen oxides and volatile organic compounds react in the presence of sunlight, and that's going to chemically create ozone, which is a primary component of smog. But nitrogen oxides and volatile organic compounds are also components of smog, in addition to things like particulate matter, such as soot, ash, or dust. There are also a couple other components of smog that aren't as important for this class, but if you see them, they might pop up. So I just want you to be familiar with the terms. PANs, which stands for peroxyacetyl nitrates, and something called aldehydes. These can also compose smog. So smog is I guess you could kind of think of it as like a tertiary pollutant. It is a mixture of primary and secondary pollutants. And like I said, smog is formed when nitrous oxides and VOCs react under high heat or sunlight. This can happen in power plants, car engines, boilers, coal power plants, etc. And then that forms ozone, and ozone combines with other photochemical oxidants and as well as primary pollutants like particulate matter and NOx and VOCs to form smog. Photochemical oxidants, photo means light, chemical means chemical, so these are molecules that are formed into the presence of light, and they oxidize other molecules, which basically means that they're ripping electrons off the molecules, which is really bad. It can lead to degradation and destruction of these molecules. This is an example of an aldehyde functional group. If you took biology or chemistry, you may have seen that before. Excuse me. You might be a little bit rusty on what VOCs are, volatile organic compounds. So let's review quickly, right? They are basically any chemical that has a smell. They're organic, meaning that they contain carbon, and they evaporate very, very quickly. That's why they are called volatile. They evaporate quickly, which means that they have a strong scent, usually. They could be natural. Trees produce things like terpene, which is that sappy, piney smell, but they could be anthropogenic as well. Things like paints, turpentine, gasoline, ethanol, nail polish remover, etc. Almost any scents that you smell are going to be volatile organic compounds, and they can be extremely harmless or they can be extremely toxic. But when they react with NOx in the presence of sunlight, they can produce ozone, which can lead to smog formation. Right? So like I said, smog is a mixture of all these different sorts of things combining together. Oh, hi Dora. Oh, Dora's got a question for us. Oh, Dora, this is such a good question. I'm so glad to see that you've got your inquisitive mind equipped and ready to engage in some critical thinking. What factors affect smog formation? Great question, Dora. And in order to answer that, we should go back to our diagram here. Smog is comprised of these different things: ozone, particulate matter, etc. So what are the factors that affect ozone formation, the primary ingredient in smog? Sunlight, NOx, and VOCs. Well, we can't really alter the amount of sunlight, so to speak, but we do have impacts on the amount of nitrogen oxides and volatile organic compounds. So when are these, what factors affect these three things? Well, time of day is going to have a big impact because nitrogen oxides are released from cars during when they're combusting in their engines, right? The combustion of gasoline or diesel will produce nitrogen oxide. So that time of day is going to have an impact because of rush hour in the morning. But additionally, time of day is going to impact the amount of sunlight that is present, required for ozone to form. So we're going to see that NOx is released earlier in the morning when all of these cars are commuting to work, and then later in the day, ozone will start to increase as the sunlight becomes stronger around 1 or 2 p.m. And we'll look at a graph of this in class. But wind also can have a big impact. Smog doesn't stay put. This is a photo from China. It shows the same area 4 days apart. You can see it's very smoggy on one day, and the wind blows it away. 4 days later, it's clear blue skies. Other factors that impact smog formation are topography, the geography of the surrounding land. If there are valleys or basins, smog can get trapped in those basins, and mountains. Things like rain shadows, we talked about earlier in the year, can impact it as well. If we look at LA, this is a diagram showing LA, it's got an ocean breeze coming in from the west, which is going to push all the air westward, but it's got mountains to the east, so all of that air is going to get trapped here, and if there's pollutants in that air, if there's smog forming in that air, it's going to stay there. It's going to stay condensed and concentrated in that basin, trapped between the cool sea breeze and the mountains. And additionally, there's something called a thermal inversion, which is an atmospheric phenomenon that can trap air beneath a layer of warm air. So basically what happens is in the troposphere, as you go up in altitude, the air gets cooler and cooler as you go up. Right? The molecules become less dense. They're not as good as trapping heat. So as you go up, it gets cooler. During a thermal inversion, what happens is the temperature gradient flips. It inverts. And instead of having warm air that is rising, we see that as you go up in the altitude in the troposphere, it doesn't actually get colder, it gets warmer. So down towards the bottom, lower altitudes, the air is cooler, and in the higher altitudes, the air is warmer. And this is going to trap air in that pocket of cool air because cool air sinks and warm air rises, so there's no mixture between these layers. Here we see mixture where warm air will rise, cool air will sink, so it allows the pollutants to escape. But here the cool air has sunk and the warm air has risen, so it's not going to escape, it's going to stay trapped. I'll show a demo in class that illustrates this phenomenon. You can see it again here. Under normal conditions, as you go up in altitude, it gets colder, and that allows for vertical admixture of the air, allows pollutants to escape. But in a temperature inversion, the warm air is at the top, cool air is at the bottom. Cool air sinks, warm air rises, so there's going to be no mixture between these layers, and the pollution is going to get trapped above the city. Oh, Dora, you've got another question, but we can't understand you. Your mask is blocking. You need to take your mask off, please. Okay, much better. Much better. Oh, what a good question, too. Where do thermal inversions even come from? What causes them to occur? Well, it has to do, it can happen when a warm front moves in, when there's lots of high pressure. It can happen in valleys, but the main one is when the radiation from the Earth, the heat that is radiating from the Earth is going to exceed radiation received from the sun. So here's a picture of a city in Kazakhstan with a thermal inversion. You can see this clear line of smoke, smog being trapped. Basically what happens is during the day the city is absorbing a lot of heat from the sun, and then at night the air in the atmosphere will cool off and the city will start to radiate the heat that it has spent all day absorbing. And so that heat will start to rise and you'll have a layer of hot air above the city. Meanwhile, as the city radiates its heat, it's going to cool off. And so the area around the city tends to be cooler, and all the hot air that was released from the city over the course of the evening is now above the city. So it can cause this thermal inversion. You can see it here from below and here from above. It's a pretty dramatic photo of all these smog or clouds or anything that's in the air getting trapped. And that's the big takeaway, is that these thermal inversions can trap smog and other air pollutants in the city, which is really dangerous because it concentrates the air pollution in one spot and can lead to a lot of different side effects in terms of physical well-being. It could lead to stroke, heart attack, a lot of respiratory issues like asthma, lung cancer, bronchitis. It can do damage to the nervous system. It can irritate your eyes. It can burn your throat, but it can also lead to depression, anxiety as well. Oh, hi, Dora. Gee, she's just all over the map today. She keeps coming back. And she's got another question. And you know what? This is a great question. I'm glad that she's always thinking on the optimistic side, wants to make some change, wants to improve some of these problems, and she wants to reduce photochemical smog. Dora, I'm really glad to have you here to guide this discussion. Thank you so much. So what can we do? Again, we need to return to this diagram. These are the factors that influence smog formation. So we need to reduce the amount of particulate matter, VOCs, and nitrogen oxide. We can't really alter the amount of sunlight, and that's kind of out of our control, so to speak. So what can we do? We can drive less and take care of our cars. That's going to reduce the amount of VOCs and nitrous oxides they emit. We want to avoid products that release high levels of VOCs, like paints and stuff like that. And if you're using them, make sure you're keeping them covered. Avoid using gasoline-powered equipment when you can. Right? Not everybody is necessarily going to hook up a lawnmower to their bicycle, but get creative. And a big one we can do is not idle. Idling our cars in the parking lot while we wait for someone to pick up our food or whatever. Idling is dangerous because, yes, it produces CO2 when you're not moving, but the big thing is that it keeps the engine warm. And in doing so, it's facilitating this reaction, right? This reaction it requires heat. So it can't happen in sunlight, but it can also happen from the heat emitting from your car engine. So by not idling, you're reducing the amount of excess heat that your engine is producing and reducing the formation of smog. We can also look at legislation. The Clean Air Act has had a massive impact on smog levels. You can see since 1975, the smog levels has been dropping substantially. Well, this is ozone, but we can use ozone as a proxy for smog. So you can see there's been some bad years perhaps, but the general rate is that it's decreasing, which is great. And we've seen declines in other major pollutants as well, that are major components of smog, such as NOx and VOCs. So legislation is going to have a big impact on smog, as well as the behavioral changes that we can make. So that's all I've got for you today. If you've got questions, bring them to class, and I will see you then.